Course to Fine, Facial Structure Editing of Portrait Images via Latent Space Classifications. We present a novel method that can automatically remove the double trin effect in portrait images as a case study of editing facial structures. Our core idea is to train a fine separation boundary that enables us to eliminate the double trin appearance of portrait images by editing their latent codes while preserving face identity. The images on the left are input images with visible double chin. Our method can automatically generate new portraits without a double chin while faithfully keeping other regions unchanged. See the images on the right. We first describe the neck mask net that extracts the neck mask. Given a portrait image with a double chin as input, we union the face mask and neck mask predicted by face parsing, then use the face alignment approach to extract chin landmarks. The polyline composed of chin landmarks refines the outputs of face parsing. Then we describe how to eliminate a double chin in detail. The input portrait image is fed to a StyleGAN projector to get its latent code. We use a proposed fine separation boundary that directly edits the latent code and eliminates the double trin while preserving face identity. After applying the style mixing approach to the new latent code and the input latent code, we generate a new portrait image. To address the subtle misalignment in the new portrait image, we perform a warping process. We input the original image to neck mask net and get the neck mask, and then we perform anti-aliasing at the mask boundary to achieve smooth editing results. To locally alter the neck region while keeping other regions unchanged, the neck mask is used to copy and paste the neck region of the new portrait image onto the original image and get the result. Next, we elaborate on how to get the fine separation boundary. We randomly sample 50,000 latent codes, input them into the StyleGAN generator to get generated images. Then we use a double trin classifier to label all these images and build the coarse separation boundary training dataset containing latent codes and their scores. For the coarse separation boundary training, we first choose 15,046 latent codes as well as their scores and then use a support vector machine to train the coarse separation boundary. To achieve the fine separation boundary that has better performance in face preservation than the coarse separation boundary, we employ a carefully designed pipeline. For each input latent code, the StyleGAN generator outputs its corresponding portrait image. We first use the coarse separation boundary to edit the latent code. Then we apply the truncation trick and stack operation to latent codes, map them to the W plus latent space and apply the style mixing approach. The edited latent code is input to the generator to get a portrait image with a new chin. The original image is fed into the neck mask net to extract the neck mask, which is then employed to get an intermediate synthetic image from the two portrait images, serving as a better facial prior. There exists a visible misalignment in the intermediate image. Therefore, we apply a diffusion method to eliminate the problem. We input the intermediate image, neck mask, and the latent code into the diffusion process, getting an optimized latent code along with the result portrait image. Finally, we leverage the optimized latent codes to train a fine separation boundary. We also build up a dataset with paired images, where the double trin removal is based on our method. We first generate 13,990 portrait images, which have visible double chins. Then we use our proposed method to remove the double trin in those images and get a trin editing dataset. We compare our method with existing face editing methods, including mask GAN, SCFE GAN, and painting. By changing the hyperparameter in our method, we can further quantify the degree of double chain removal, as shown in the video. Thank you for your watching.